The universe is brimming with mysteries from the backyard of our solar system to the far-off shores of the cosmic ocean. That is how it has always been. Centuries ago, ancient astronomers were mystified by the nature of comets and wondered about the chemical makeup of stars. These ancient puzzles have been solved, but new puzzles have taken their place as bigger telescopes and more sensitive tools look further into space. Now we marvel at black holes, the fundamental nature of physical principles, and the position of the universe in general. When you look at the 5 greatest mysteries, you'll come to see that one thing is crystal clear. The universe itself is the greatest mystery of all. Cosmologists are feverishly attempting to unravel its origin, makeup, and future. They're not there yet, but over the next few decades, solutions might very well be at hand. And by then, who knows what new mysteries we might have learned to ask. In the meantime, here are some of the biggest mysteries concerning space, the cosmos, and just about everything in the universe. How do galaxies form? Areas that had a tiny higher density attracted more matter and increased with time, whereas vacant areas became emptier. Thus, despite the universe's expansion, the matter was drawn into clumps that eventually developed into galaxies, like the Milky Way. Cosmologists use massive computer simulations, like the enormous Millennium Run carried out by Durham University scientists to explore the formation of galaxies in an expanding universe. Yes, astronomers can simulate the universe on a computer. Following that, the statistics of the distribution of galaxies are compared to the known large-scale structure of the universe. The good news is that one particular model closely matched the observed universe, one in which the majority of matter is made up of dark particles that barely interact with ordinary atoms. This concept predicts the filamentary structures should connect galaxies and galaxy clusters, and some discoveries seem to confirm this idea. However, there's a catch. The models also suggest that large galaxies are surrounded by a large number of smaller galaxies. Although these are not seen, the formation of the first big galaxies so soon after the Big Bang also remain a mystery. What caused the Big Bang? This is a pretty insightful question. To find out the cause of the Big Bang, you assume a previous event that had a universe-spawning effect. However, it's not entirely clear what the word previous means in this context. It's possible that the Big Bang resulted in the creation of space and time as well as matter and energy. It is challenging to establish a logical cause in that situation. Since this is a complex intellectual material, it is not surprising that cosmologists have attempted to disprove the spontaneous creation of the universe from nothing. Some physicists believe until recently that the universe would eventually recollapse and cause another bang. That notion, however, has subsequently lost favor because we now know that the universe will most likely continue to expand indefinitely. Instead, other physicists propose that the Big Bang was brought about by the collision of 2 universes that were floating side by side in a higher dimensional bulk space, with our empty 4-dimensional spacetime. Even more mind-boggling is this. If something caused the Big Bang, what promoted the cause? How will the universe end? Perhaps it won't. The universe may last forever even though people pass away. Planets disintegrate, stars burst, and even black holes decompose. Star formation in many galaxies won't practically entirely stop until another 100 billion years or more after the cosmic baby boom, when the stellar birth rate in the universe was at its highest. But what about the entire universe? Since the inexplicable acceleration of the universe's expansion rate, known as dark energy, was discovered in 1998, many astronomers think it will never slow down, let alone go back into contraction. Therefore, galaxies will gradually move apart in the far future. They will eventually disappear beyond each other's cosmic horizon, leaving the universe in complete darkness and alone. The mystery is in the precise sequence of events. In the extremely long run, perhaps all elementary particles are unstable, and the matter will vanish completely. Additionally, the mysterious dark energy that propels the expansion of the universe may grow stronger with time, resulting in a big rip in which space itself is split in 2. Is there life beyond Earth? It doesn't matter how improbable the beginning of life on Earth may have been. Theoretically, there should be many additional living planets in the universe. According to the argument, the observable universe has around 100 billion galaxies, each of which has tens of billions of stars. Even if only 1 planet out of every trillion of these stars has planets, there are still billions of planets in the universe that could support life. Naturally, the intriguing subject of whether or not there is life elsewhere in the universe will only be resolved if and when we discover it. Only a few places in our solar system, including the planet Mars, Europa, one of Jupiter's Galilean moons, and perhaps the warm interior of Saturn's satellite, Enceladus appears to be suitable for the existence of microorganisms. The moon's remarkable tiger stripes or fissures, along with longitudinal depressions, release ice particles, water vapor, and chemical molecules. The tiger stripes or linear depressions along the moon's surface are fissures that release ice particles, water vapor, and chemical molecules. The discovery of Martian bacteria, either extant or extinct, would immediately tell astrobiologists that life is extremely common in the universe. There is lots of evidence suggesting Mars was warmer and wetter in the past, but nothing has been discovered so far. Astronomers are just starting to detect the atmospheres of exoplanets as they begin to spread their search nets a little broader. It is almost clear that a planet must have life on its surface, if its atmosphere is found to contain significant amounts of oxygen and methane. On Earth, it took billions of years for life to evolve from single cellular organisms to anything bigger than the full stop at the end of the sentence. So our best chance of finding life may be to look for microbes. However, that limits the search for planetary systems in our near area. For this reason, some academics are attempting to eavesdrop on alien civilizations, radio communications. If they do, they might be picked up from the opposite side of the Milky Way. However, this SETI project assumes that the biological evolution of life inevitably results in intelligence and technology. Given that evolution has no inherent objectives, ask an evolutionary biologist and they could laugh in your face. And here they are. As Italian physicist Enrico Fermi once quipped, the Fermi paradox states that if there are so many alien civilizations, they should have discovered and visited us a long time ago. No matter how likely it may be right now, the presence of extraterrestrial life is still just a theory, and it's unlikely that that will ever change anytime soon. It's a humorous question because it's impossible to refute the hypotheses. Some will continue to think they haven't explored far enough if nothing is discovered. What is the universe made of? The short answer is very simple: no one knows. The atoms and molecules that make up the familiar matter that we do understand are merely the tips of a much larger iceberg. The vast majority of matter is black and made up of unidentified particles. The vacuum of empty space is filled with a mysterious dark energy that speeds up the expansion of the universe, as if that weren't mysterious enough. We are not only blind to the majority of the iceberg, but we are also unable to comprehend the murky water in which it is submerged. Dark matter can be detected thanks to its gravitational pull. The rotational velocities of galaxies, their movements within massive clusters, and the way the gravity of the clusters distorts the light from background objects recorded during gravitational lensing can all be used to demonstrate this. All indications point to the universe having around 30 times as much matter as what can be seen with telescopes. So, could faint stars, frigid gas clouds, and black holes therefore explain the existence of dark matter? Sadly, no. The universe would appear very difficult if all of the dark matter were made up of the baryons, protons, and neutrons that make up atomic nuclei. The nuclear fusion processes that took place during the Big Bang would have created a different set of elements with far less deuterium that is seen since there is so many baryons around. But if you accept the Big Bang theory, there's no way out. The majority of the universe's matter is made up of enigmatic non-baryonic particles. There is also dark energy, a striking name, but nobody is sure what it is. Astronomers found in 1998 that the universe is expanding at a faster rate than it did a few billion years ago. Contrary to expectations, it appears that the universe is expanding faster despite the gravitational pull that galaxies have on one another. This acceleration is attributed to dark energy, which can be compared to the compelling force of empty space. So there you have it, the cosmology concordance model. Dark energy makes up roughly 70% of the universe's total mass, with matter making up the remaining 30%. However, only a small portion of this matter, that's 4% of the universe's total mass, is made up of ordinary particles, and only about 25% of this baryonic matter, 1% of the total, is visible to humans in the form of stars and gas clouds. Undoubtedly, that is a strange tale. Still, most cosmologists are happy with the concordance model. The majority of the universe's features are explained by it, and a range of measurements, including detailed temperature maps of the cosmic microwave background radiation, maps of the Big Bang's afterglow, and three-dimensional maps of the distribution of galaxies, just seem to support it. The puzzle seems to fit together perfectly, but the only issue is that no one knows what it represents. The biggest unsolved mystery in astronomy is the nature of the universe. Alright guys, that wraps up our video for today. If you enjoyed watching this, please give us a thumbs up and hit the subscribe button for more.